Hello everyone, welcome to the video on evaluating limits. Before I jump into evaluating limits with different indeterminate forms and whatnot, I want to cover some of the core limit properties before we go ahead. So let's jump right in. Constant rule, the limit as x approaches a of c is going to be c. So if you have a constant, it's going to be a flat line like that across the plane. So if you take the limit from either direction, it's always going to be the same value c. Identity rule, as x approaches a, as x approaches a of x, x is going to equal a. I mean, that also should make sense, right? If you're approaching a with x, it should also equal a. There's no other conditions, no other like holes in the function that there could possibly be. So yeah, that makes sense. Then come the addition and subtraction laws, multiplication law, division law. These are essentially the same. So the limit as x approaches a of f of x plus or minus g of x is the same thing as the limit as x approaches a of f of x plus or minus the limit as x approaches a of g of x. The same thing for the multiplication law. The limit as x approaches a of f of x times g of x is going to be the limit as x approaches a of f of x times the limit as x approaches a of g of x. And then the division law, all this is really saying is you can take in and out that limit operator in a sense. So the limit of f of x divided by g of x as x approaches a is the same thing as the limit as x approaches a of f of x divided by the limit as x approaches a g of x. Then comes the power law. The limit as x approaches a of f of x to the power of n is the same thing as the limit as the limit of f of x as x approaches a with the whole thing raised to the power of n. So you can just take in or out that limit from a power and from an exponent, and the composition law. So the limit as x approaches a of f of g of x is the same thing as f of the limit as x approaches a of g of x. Yeah, that's about it. These may seem like pretty basic laws, but they're important to discuss when you get introduced to a new mathematical object. Well, you might see in linear algebra that, or other subjects, that it might not be as straightforward. You might also see that in the quotient rule when it comes to finding derivatives, or the product rule. All right, so let's get on with our first example of evaluating limits. This is probably the easiest example, direct substitution. It is exactly how it sounds. So let's say we have the limit as x approaches 4 of 3x minus 5. I mean, it's a pretty simple function, but all you have to do is sub in 4. That's it. So 3, 4 minus 5. So 12 minus 5 is equal to 7. All right, so we have the limit as x approaches 2 of x squared minus 4 over x minus 2. Let's do that now. If we were to sub this directly in, like we were trying before, 2 squared minus 4 over 2 minus 2 will give us 0 over 0. This, in particular, this we often describe as something called an indeterminate form. This usually means that there's some other trick that you can pull out of your calculus toolbook to try something else. There's also other indeterminate forms such as infinity over infinity, or we'll get into that later. Let's get into this expression. Right away, some of you might have been able to see that you could just simplify this down to x minus 2, x plus 2, and completely factor out the x minus 2 at the bottom. And that would give us x plus 2. And in which case, this is what you would typically do for most problems when you get an indeterminate form and you can see this sort of factoring going on, right? So if we were to sub in 2 here, we get 2 plus 2 gives us 4. So therefore, this limit of this expression will approach 4 as x approaches 2. All right, let's try another example. Let's try the limit as x approaches 2 of 15 x cubed minus 30 x squared over x to the 4th minus 4x squared. I don't have a calculator with me, so I shall just do this out by hand. Let's see what happens as we sub it in. So 2 to the power 3, right? 30, 2 to the power 2, that's 2 squared, 2 to the power 4, 4, 2 to the power 2. So this right here is going to be 8. 15 times 8 is 120. Yes, 120. And then 2 to the power of 2 is going to be 4. 30 times 4 is going to give us also 120, as it comes to no one's surprise here. 2 to the power of 4 is going to be 16. 4 times 2 times 2 is also going to be 16. So this will be 16 minus 16, which gives us 0 over 0, another indeterminate form. So let's do some factoring, some simplification. I'm going to do this separately. So 15x cubed minus 30x squared over x to the 4th minus 4x squared. Right away, I'm just going to factor out this 15x squared from the top. So this gives us, let me redo that. This gives us x minus 2 times 15x squared at the top, and x squared times x squared minus 4. Yeah. So these two cancel out. X squared times x squared. You might already see something with these two expressions right here in terms of difference of squares, and we shall get right into that. So 15x minus 2, we break this down using difference of squares. We get x minus 2, x plus 2. And these two cancel out, giving us 15 over x plus 2. Coming back to our original limit, we were seeing what happens as we approach the value 2. So if we sub in 15 over x plus 2 into this expression, or 2 into this expression, sub in 2, we get 15 over 4. All right, let's try another example where we have to multiply by the conjugate. So let's write this over here. Let's multiply this entire numerator by x plus 1 plus 1 this time. Multiply the denominator by the same thing to keep the same value. X plus 1, and you end up getting x plus 1 minus root x plus 1 plus root x plus 1, and then 1, negative 1 times 1 is going to be negative 1. So this is going to cancel out with this, and this positive 1 is going to cancel out with this negative 1. All of that over x times x plus 1 plus 1. Right? And let's just draw this over here again. X over x times square root of x plus 1 plus 1. This x cancels out with this x, and we're left with a final expression of square root of x plus 1 plus 1. And we are seeing what happens as we approach the value 0. So let's sub that in. Let's plug in 0. 0 plus 1 is going to be 1. The square root of 1 is also going to be 1. 1 plus 1 is going to be 2. So the limit as x approaches 0 of this expression over here is going to equal 1/2. All right, let's try one more example using trig identities. So the limit as x approaches pi over 2 of 3 cos squared of x over 2 minus 2 sine of x. You might be able to see something happening here with the trig, with the Pythagorean identity, and that's exactly what we're going to do. Right? So 3, 1 minus sine squared of x over 2, 1 minus sine of x. And then factor, use difference of squares to separate out the 1 minus sine squared of x to 1 minus sine of x and 1 plus sine of x over 2, 1 minus sine of x. Cancel these two out, and you're left with 3 over 2 times 1 plus sine of x. And we know that we are approaching the value pi over 2. So if we sub in pi over 2 in here, this would become 1. 1 plus 1 is going to give us 2. So 3 over 2 times 2 is going to give us 3. Therefore, the limit of 3 cos squared of x over 2 minus 2 sine of x is equal to 3.